Bright Duty. Every student matters.
In a triangle ABC, D, E, F are respectively the midpoints of AB, BC and CA. So D is a midpoint, so AD will be equal to DB. E is a midpoint, so BE will be equal to EC, and F is a midpoint, so AF will be equal to FC. These segments are equal. Now we need to show that ABC is divided into four congruent triangles. As you can see, that triangle ABC is now divided into four triangles, 1, 2, 3, 4, and we need to show that these are congruent triangles. How can we show that? Let us start by the given information. You write all the given information which I have shown you in the figure itself. So you write AD is equal to DB, BE is equal to EC, etc. Right? I am going to the proof directly. So let us start the proof. D is midpoint of AB, F is midpoint of AC. Now by midpoint theorem, what can you say about DF and BC? The DF will be parallel to BC. DF will be parallel to BC. Another thing that I can say about DF, that it will be half of BC, right? So this DF will be parallel to BC and it will be half of BC. So DF is equal to BE here. DF is parallel to BC and DF is half of BC. That means half of BC is also equal to BE and EC also, right? So DF is equal to BE is equal to EC. Now if you have noticed this much, it will be very easy for you to understand that if DF is parallel and equal to BE, this quadrilateral DFEB is a parallelogram. So if you know this much information, you can say DFEB is a parallelogram. Why? Because we have proved that opposite side, one pair of opposite sides is equal and parallel, and this much is enough for a quadrilateral to become a parallelogram. So DFEB is a parallelogram. In the same way, you can show that DF is parallel to EC and equal to EC. So DFCE is also a parallelogram. DFCE is also a parallelogram, right? Now similarly, you can show that this is also a parallelogram. AFED is also a parallelogram. Why? You will use the midpoint theorem and show that EF is parallel to AB and is half of AB. So you can easily show that AFED is a parallelogram. Now once you know that these are parallelograms, let me talk about one of these parallelograms. So let us talk about parallelogram DFEB. Parallelogram DFEB. DFEB. So if you notice this parallelogram, DE is the diagonal of this parallelogram. DE is the diagonal of this parallelogram. Now what is the property of a parallelogram? That diagonal of this parallelogram divides it into two congruent triangles. Diagonal of a parallelogram divides it in two congruent triangles. So this triangle is congruent to this triangle. Similarly, you can notice that this is a parallelogram and this is a diagonal. So this triangle is congruent to this triangle, and similarly this is a parallelogram and this is a diagonal. So this triangle is congruent to this triangle, right? These two triangles are congruent, and similarly this being a diagonal, these two triangles are congruent. So what we have proved here is that this triangle is divided into four congruent triangles by joining D, E and F. And what have we used in this one? The midpoint theorem to show the quadrilateral DFEB and DFCE AFED are parallelograms. And then the second concept that we used here is that the diagonal of a parallelogram divides it into two congruent triangles, right? I hope you have understood this concept. Let's move to the next one. LMN are three parallel lines intersected by transversal P and Q. So these are lines LMN and these are transversals. Show that LMN cut off equal intercepts DE and EF on Q also if they have cut equal intercepts AB and BC on P. So what is given is that AB is equal to BC, and we need to show that this DE is equal to EF. This is equal to this. This is what we need to show. Okay, so I'll use midpoint theorem because LMN are parallel. So if I look at this triangle here, let me change the color. Okay, so if you look at this triangle ACF, B is the midpoint, B is midpoint of AC, and BG is parallel to CF. This much is given. So by converse of midpoint theorem, that we have just proved, I can say G is the midpoint of AF, right? Now once you have shown that G is midpoint of AF, that is this segment here is equal to this segment, now you notice that in triangle AFD, GE is parallel to AD. Why? Because L is parallel to M. This is what we know already, right? So this GE will be parallel to AD, right? Another thing we know is that G is midpoint of AF, right? So again by converse of midpoint theorem, what can you say about point E? E is a midpoint of DF. E is the midpoint of EF. E is the midpoint of DF, right? And this is what we had to show. If E is midpoint of DF, then DE is equal to EF. BE is equal to EF. Hence, it is proved. Right? So you just made use of midpoint theorem, converse of midpoint theorem on two triangles, and showed that E is midpoint of DF. So how did we proceed? We already knew that B is a midpoint and BG is parallel to this. So G became a midpoint by converse. Now we notice this triangle here. G is a midpoint and GE is parallel to AD. So E becomes a midpoint by converse of midpoint.